Hey everybody, my name is Dalton Cole. I'm the Chief Technology Officer at Digital Opportunities Group. We're an asset management firm that specializes in digital assets. And today I want to talk about two of the most popular digital assets. So that's going to be your ERC-20 and your ERC-721s. An ERC-20 is commonly known as a fungible token, whereas an ERC-721 is a non-fungible token or an NFT. So the tokens that we're going to be looking at for the ERC-20, we're going to be looking at USDC or USD coin. And then for the NFT, we're going to be looking at Bored Ape Yacht Club. So Bored Ape Yacht Club is a very popular NFT collection that trades on Ethereum, much like USDC. We're using EtherScan to look at the contracts. And then we'll also take a peek at ethereum.org, where we can actually see the standards for what makes an ERC-721 and ERC-721, or an ERC-20 and ERC-20. So both an ERC-20 and an ERC-721 are smart contracts, so that just means they're essentially applications that run on Ethereum. And what that means is that their state, their memory, it's all stored as data on blocks. And that's pretty much the background of how they work. They're just applications that run on Ethereum. Deceptively pretty simple. So if we look at a fungible token, so fungibility means that one equals one no matter what it is. So if I have a USDC and you have a USDC, there's no difference in value there. Even more so, that USDC, those individual USDC units are not things. I guess you could say they're not tokens. There's no such thing as an individual USDC token. What there is a list of balances, or there's a list of addresses and then their balances. So this smart contract for USDC, it includes an implementation contract. So what that allows them to do is upgrade. See if that'll, whatever reason it's not running, but the implementation contract is this here, and that allows them to upgrade. So they can keep this master contract, and then they can update what implementation it points to. And so the actual information is going to be here. So if we want the total supply, that's a total supply of USDC. But if we wanted to read the code, we would actually need to dig into this implementation contract, which is fiat token v2. So if USDC wanted to update some of their underlying logic, they would deploy a new implementation contract and point the master contract at that proxy. Okay, so if we want to look at how this works, we'll just go into the basics. So we'll probably just talk about minting and transfers and the actual state. So we can see that it's an ERC-20, which is, like I mentioned, was the fungible side. And then we can look here. So in order to satisfy the requirements of the standard, it's going to have a specific amount of methods or a specific list of methods. So it needs to have a name. In this example, it's going to be USD coin. A symbol, it's going to be USDC. Decimal, 6 decimals for USDC. A lot of times you'll see 18 decimals on other contracts, but USDC is 6. A total supply, so that's going to be the amount of USDC that exists. So if you were to sum up all the balances of every address, it should equal total supply. You'll have a balance of method, and this accepts one argument, and that's the owner or the address of the owner. So if you gave it your address and you had some USDC, it's going to tell you how much USDC you have. There's a transfer function, so that's who are you sending the money to and how much. So if you call that from your address, then you are the from person in that agreement, which is what the transfer from would represent. If you're signing it yourself, then the signer is considered the from. So we'll dig into how that works. They both, I think, call the exact same method, which you see is like an underscore transfer that has the same arguments as the transfer from. That value, so when you transfer, all that's going to happen is that your balance in the memory of this contract is going to be reduced by what you transfer, and the recipient is going to be increased by what you transfer. So that keeps the total balances in line with total supply. There's approve, there's allowance. We can get into those on another video, maybe when we go over security. And then there's events. So these are emitted events, so that anybody's listening for specific events will see what's going on. Okay. So that's what makes an ERC-20 token an ERC-20 token. You'll notice that there's a lot more methods here. So each person can add on, or whoever deploys the contracts can add on new methods if they'd like to. For example, there's a master minter here. So if we look at who the actual master minter is, you have to go back to the original contract. And this is the master minter. So this is who can mint USDC. So if we want to look at how USDC is minted, go here and we'll look up mint. Be a lot of clicking because I want to look at different things going on here. Okay, well, we can start here. Okay, so this is the actual token contract. When I said that it was just a list of addresses, that's what it's saying right here, is there's a map of addresses that represent internal balances. So we can actually go over here. I've got a little Excel spreadsheet. So we'll just have address, balance. And so address, let's say 0x1234, address 0x1235. Say his bad address is 100, his address is 100. So when you call the, let's say the master minter calls a mint function, all they're going to do is go in and say, okay, we're going to mint 50 USDC. Well, this guy gets 50 USDC. And so they've increased total supply here. They also have a number that's, let's see where that is. Should have a total supply number. Let's see where it's. All right, total supply here. So they'll actually increase that total supply by 50 as well. But we'll look at that in just a second. Okay, well, here's the mint function. So only minters can call this. They can only call it when the contract is not paused, and you can kind of look at those requirements elsewhere in the contract. Just look them up. USDC has a blacklisting method, which allows it to maintain a list of people who cannot perform certain transactions. So in this example, you cannot mint to a blacklisted address. You cannot mint from a blacklisted address, which makes sense because only minters can call this. It would be strange if they blacklisted a minter, but they do have that capability in there. Then there's some additional requirements. You cannot mint an amount to a 0 address, and you cannot mint an amount that is less than 0. Or the mint amount must be greater than 0, in other words. Okay, and then in USDC, each minter has a max allowance on what they can mint. So it needs to make sure that the amount is not greater than the minter's allowed amount. Okay, so once it satisfies those requirements, then all they do is they take that minting amount. So in this example, they're minting 50 USDC. They'll increase the total supply by 50 using this add method. So they'll add 50 to total supply. The balance is 2. So in their balances map, they'll look up the 2 address and they'll add the amount to the balance of that address. Okay, and then what they'll do is they'll go to the allowed minters list, look at how much they're allowed to mint, and subtract the amount that they minted to keep in line with their requirements on, minters can only mint so much, and then they emit these messages here. So essentially saying, hey, we've minted this much to this address, and then they also call transfer because those funds were not technically transferred. They were transferred from a 0 address. They were minted out of thin air. Hopefully there's some USDC floating going, or US dollars going into some account that accommodate for that, or account for that, but that's essentially what happens in the mint function. So whoever is the master minter, they say, hey, I'm minting 50 USDC. They have to know who they want to mint it to, because an address always has to be the recipient. They mint it by increasing total supply, which is just a number. They're just adding to a number in this contract, and they're just adding to a balance. So it's just simple arithmetic here going on behind the scenes. And then the real magic is just a list of addresses and their balances. Pretty simple stuff. So there's not actually like a USDT, right? There's just addresses with balances. They go up and down. I'm sorry, USDC, not USDT. So yeah, this is essentially an ERC-20 token. Balances for addresses. Okay. I think I mentioned also we'd look at transfer. So there's 2 transfer methods. There's transfer and transfer from. Both of them call after passing certain validations. This transfer method, underscore transfer, you actually see here transfer from, assuming it's allowed passes an allowance not blacklisted, it's going to call the transfer method. Same with transfer. Make sure it's not blacklisted, then it calls the underscore transfer function. Okay. And then what that has is a from address, a to address, and a value. So if you were transferring from 1234 to 1235, what would happen? Assuming it meets all of these requirements, that it's not from a 0 address to a 0 address, that it's not more than your actual balance, it's going to subtract from the from address, add to the to address, and then emit a message that says it's been done. So in this example, you would take 10 away, you would add 10, so this would be transfer of 10. Ooh, too much. We wouldn't want that to happen. And so total supply stays the same, but the balances change. That doesn't look right. I think I did the math wrong there. What did I start with? Yeah, so it's 90, and I think it was 150, so we'll make it 160. So total supply is the same after that 50 was minted earlier. Okay, and that's really the core of an ERC-20. You've got minting for creating new. I'm not sure if minting is even required. Yeah, because you could actually just start with an amount and send it to an address. You don't necessarily need the mint and burn function, but for USDC there is a mint and burn to handle the on-ramp and off-ramp of US dollars. So that's how USDC works. Okay, now let's look at Bored Ape Yacht Club and the ERC-721 standard. So we mentioned the balance of method on USDC, or the ERC-20. That's going to tell you how much USDC is assigned to your address. So when you look up the address map, put in your address, it says this is how much they have. For the ERC-721, this is actually going to tell you how many NFTs you have. So if you have 5 Bored Ape NFTs, this will return 5. One method that is not included in an ERC-20 that is in a 721 or an NFT is the owner of, because you cannot give a single USDC and say, hey, who owns a specific USDC? Because it doesn't exist like that. It's not possible to single out one USDC, or whatever the 6th decimal place of a USDC is. There's no way to say who owns that specific amount. You can only say how much does this address own. Well, in the NFT, you can say who owns that specific NFT. All you have to do is pass in the token ID, and it'll tell you what address owns it. Transfers work very similarly. Instead of transferring an amount, you're actually transferring a token ID. But yeah, the biggest difference is going to be this owner of. So if we look at the Bored Ape Yacht Club contract, okay, this does not have a proxy contract for upgradability, which is okay. And we'll look at how these are minted. Actually, we can start with the transfer because it's right here. So for the transfer, as I mentioned, you have a from, a to, and a token ID. If you remember on the ERC-20, there was no token ID, there was an amount. So you're sending an amount of USDC, and this you're sending a specific NFT. Okay, it requires that the from address be the owner of the NFT, which is very smart. Otherwise, I could send somebody else's NFT. You need to make sure that the transfer is not going to a 0 address. Okay, there's some other stuff that's going on. Make sure things are approved. Okay, and then the token owner set to. So essentially all you have to do is look up the token and say, okay, the new owner is whoever was in this address to. So if we look at our little Excel spreadsheet here, instead of having an address and balances, what you have is token IDs and owner. So that's how this map would work. So you have 3 NFTs there, and then you have their owners. Okay. So if you wanted to transfer an NFT, you would just change the owner attribute of that token ID. So now this owner owns 2, and so there's actually another map within the this contract that says how many do people own. So you've got a map of token IDs, who owns them, and then you also have a map of addresses and how many they own. which makes it nice for essentially calculating scoreboards. Like, where do I see holders? Here we go. So this number here, what you would get from the balance of, and that's how many Bored Apes they own. Okay, so we've got that. The transfer, as I mentioned, instead of amount, you're just transferring a token ID, which just means you look up the token ID and change who is in that owner box next to it. If we want to look at minting, okay, so let's look at how NFTs actually work. So this is an art NFT, so there's a picture underneath it. That picture is not stored on the blockchain. The actual metadata around that picture is not stored on the blockchain. What is stored is okay, so when they mint, they just take the token ID, assign it to an address. So what we actually want to look at is when that initial token URI is set. And we'll go over token URI in a second. Okay, so token URI is essentially the web reference or the URL that points to the metadata of that NFT. So when you're creating the NFT, you take your token ID and then you attach it to a token URI so that you don't have to store all of that information on the blockchain. So yeah, if we want to read the contract, we've got a token URI. So we want to look at 100. So this is token ID 100. And it's going to give us an IPFS link. So IPFS is the Interplanetary File Service, and that's a distributed file store. It's supposed to be super redundant. You might see people that are actually storing these on their own servers. So you might see a traditional HTTP or HTTPS. And at that point, you're just trusting that that server doesn't go down, or else your metadata would not resolve. With IPFS, hopefully that is eliminated. So let's look up, yeah, let's do this. Okay, we're going to look up Bored Ape 100. See how that would work. All right, we'll just go like this. Okay, so this is Bored Ape 100, which is the same one that we've looked up here. So we have the token URI for Bored Ape 100, and then we have what Etherscan shows as Bored Ape 100. We have the address. They show, I don't see attributes, but if you looked like OpenSea or something like that, you would actually see the attributes. But let's look it up on IPFS and see what we see. Alright, so I had to go through a public IPFS gateway. So this is going to be the ipfs.io/IPFS. And then I just add in the endpoint that's provided here for that token URI. And so what it's going to tell me is the image address. So that's where the image is stored on IPFS. You can tell based off of this, as well as the attributes. So if you were to look at OpenSea, it might tell you the different attributes of an NFT, which helps kind of align with their rarity. So you have a yellow background, a cigarette in their mouth, party hat, dark brown fur, wide-eyed. So if we look at the actual Bored Ape, party hat, cigarette, wide-eyed, dark brown fur. Okay, so if we wanted to actually know what the image looked like, so Etherscan isn't building this image off of the attributes. There's actually an image that was already created by the Bored Ape crew, and they just reference it. So what they'll do is they'll upload all of the images of the Bored Apes, and then they'll create metadata that references those image URLs, and then that's going to create this metadata, and then within the contract they'll create the actual token IDs and assign them to the metadata URLs that already exist. And that's how you create an art NFT. There's other types of NFTs. We're just focused on art ones right now, just because they're little bit easier to follow, and a lot of people don't understand how they work. So one thing about art NFTs, you could say the same thing for USDC or ERC-20s, is the only thing that really matters is this contract address. And why do I say that? And that's because I could clone every bit of this code. I could clone all the token URIs, assign them to the exact same token IDs, and then I essentially have a perfect clone of the Bored Ape Yacht Club collection. The only thing that I would not have is the trading history because my contract is fresh. And I would not have the official Bored Ape Yacht Club contract address. Whoever controls that address essentially controls the Bored Ape Yacht Club, and it's not the images behind them that make them unique. It's not any of that. Essentially, if it's a legitimate Bored Ape, the only way to know is the contract address. Same with USDC. You could clone all the code, make your own USDC. But the only thing that makes it legitimate is whether it's the official USDC contract. That's the only one that's going to be essentially would say honored by the people that redeem USDC. That's the only thing that's going to work in USDC specific liquidity pools. It's not the name or the symbol that represents USDC. It's this contract address. Same with Bored Ape. If this contract address is not the official one, but the picture looks the same, the attributes are the same, it's not going to be worth the same. Because people want official Bored Apes. Same if you got a counterfeit purse or shoes. They may look the same, but they were not made from the official factory or designed by the official person or signed by the artist's signature. This contract is what makes it official. And then, so if you're looking at an NFT collection, you're going to want to make sure that you know what the contract is. So Bored Ape Yacht Club. Contract is this. There's probably another Bored Ape Yacht Club with a different contract that is illegitimate. You go to their website. They probably have an FAQ somewhere that says what's the official contract. They're probably too cool to make that easy to find. Okay, yeah. So here's the Bored Ape Yacht Club contract address. BC ends with 3D. Starts with BC, ends with 3D. So this is the official one. You want to get it from their website. They've got a lot of information here. It's possible their website gets hacked, someone changes the address. There's all sorts of risks going on. You just want to make sure you're working with the real deal. So yeah, that's what is different about a ERC-20 and ERC-721. ERC-20 is fungible. There's no such thing essentially as a single USDC. There's only a list of addresses and their balances. On an NFT or an ERC-721, there's a list of token IDs and they have owners. That makes them unique, and the token URI is where a lot of the metadata is stored for generating your images or your attributes. If it's a game object, maybe it's got power levels or something like that. But it would easily be possible for multiple NFTs to have the same token URI. You don't see that too common, but it's certainly possible. Yeah, thanks for tuning in.